MCB, Miniature Circuit Breaker, Step-by-step Working Principle. Here's a clear, practical, step-by-step explanation of how a typical MCB works, what parts do what, and what happens in normal, overload and short-circuit conditions. Quick overview: what an MCB is. An MCB is an automatic switch that protects an electrical circuit from damage caused by overloads or short circuits. It interrupts current flow when current exceeds a safe value, and it can be reset manually after clearing the fault. Main parts: simple. 1. Fixed contacts and moving contacts complete the circuit in normal condition. 2. Bimetallic strip provides the thermal overload trip. 3. Solenoid magnetic coil provides the magnetic instant short circuit trip. 4. Arc chute arc splitter extinguishes the arc when contacts separate. 5. Trip mechanism latch holds the contacts closed and releases them to open on trip. 6. Toggle handle manual on-off reset. Step-by-step behavior. 1. Normal operation. Current flows from supply fixed contact moving contact load. Bimetal strip warms a little but stays within normal range. Magnetic coil remains inactive, magnetic force proportional to current but below trip level. Contacts remain closed, circuit is powered. 2. Small overload, moderate overcurrent, higher than rated but not a short. More current bimetal strip heats up progressively, Joule heating. The bimetal is made of two metals with different thermal expansion, it bends as it warms. After a time that depends on magnitude of overload, the bimetal bends enough to release the trip latch. Trip latch opens the moving contact, contacts separate, and the circuit is interrupted. This is a time-dependent trip. Higher overload, faster trip. This protects against prolonged overcurrent that would overheat wires. 3. Large overload or short circuit, very high fault current. High current produces a strong magnetic field in the coil. The magnetic force acts on an armature and instantly releases the trip latch. Contacts separate very rapidly, typically within milliseconds. This is an almost instantaneous trip, magnetic trip, to clear severe fault currents and protect wiring and devices. 4. Contact separation and arc formation. When contacts separate under load, an electrical arc forms between them. The arc chute arc splitter forces the arc into many small segments and increases the arc length, cooling it and reducing voltage across it until it extinguishes. Modern MCBs are designed to interrupt arcs safely at low voltages used in domestic and light industrial systems. 5. After trip. The toggle moves to the trip position or to off. The faulty circuit should be inspected cleared. Once the fault is removed, the MCB can be manually reset, toggle on, unlike a fuse which must be replaced. Why two trips, thermal plus magnetic? Thermal, bimetal, protects against moderate, sustained overloads, prevent overheating. It gives time delay behavior, some temporary surges, like motor starting, are tolerated. Magnetic, coil, protects against short circuits and large instantaneous faults, it must act instantly to prevent catastrophic damage. Characteristic curves and types B, C, D. MCBs have trip curves that describe how fast they trip at multiples of rated current in. Common types for single-phase household use. Type B, trips at ~3, 5 times in, used for resistive loads and domestic lighting. Type C, trips at ~5, 10 times in, used for circuits with moderate inrush, motors, fluorescent. Type D, trips at ~10, 20 times in, used for heavy inductive loads with large inrush, transformers, big motors. These are standardized so you choose according to expected inrush and protection needs. Ratings you'll see on an MCB. Rated current, in example, 6A, 16A, 32A the continuous current the MCB carries without tripping. Breaking capacity, ka maximum fault current it can safely interrupt, example, 6K, 10K. Poles, single pole, double pole, triple pole, depending on single three-phase. Trip characteristic, B, C, D etc. Example sequence, short summary. 1. Normal, contacts closed, current is equal to in. 2. Overload, 1.5 times in sustained bimetal heats bends releases latch opens circuit after time delay. 3. Short circuit, 20 times in magnetic coil actuates instantaneous release contacts open within ms arc extinguished by arc chute. 4. Reset, manual toggle back to on after fault clear. Practical notes and safety. Never bypass modify an MCB. It's a safety device. Select MCB type and rating to match conductor size and load characteristics to avoid nuisance trips. For critical or industrial systems, coordination, selective tripping between upstream-downstream breakers should be designed by an electrical engineer.